grade 10 learners at a school. 55 learners offer mathematics. They're supposed to be saying are doing what? The mathematics. And then 80 offer life sciences. There are 25 learners who don't do mathematics or life sciences. It's very much possible. So the first question says, represent the information in a Venn diagram. Okay, now in grade 10, as I've said in the past, we mainly concentrate on two events. Okay, in grade 10, it's two events. Grade 11, three events. Okay, so here we have got two events. Our two events are the two subjects, mathematics and life sciences. All right? So, first, we need to draw the Venn diagram. Okay, so I'm going to draw my Venn diagram first, and then indicate my. So we have two events. So that's mathematics, and then we have got life sciences. So I'm going to abbreviate mathematics by a capital letter M and life sciences by a capital letter L. Or you can put LS, fine, like that. Right? Please always, when you're drawing a Venn diagram, if you are not given the diagram, okay, it's always better to make sure that your two events overlap. Okay, it's always better to do it that way. The advantage of that is even if there is no overlap, if you do a calculation, you might see that there is no overlap, then you can redraw without an overlap. But don't assume that there is no overlap. Most questions on Venn diagram, there is an intersection between two events. Okay? And even if you draw the first Venn diagram incorrectly, if you realize that there is a mistake, you can always what? Redraw it. Okay, so when you're drawing the Venn diagram, first check if there is anything which is common between the two events. So in this question here, there is no information provided that there are learners who are doing both mathematics and life sciences. In that case, we are going to call those learners X, those who do both subjects. Because the question does not specify how many are doing both subjects. Always start with the intersection. Don't let your mind wander around and start thinking, where should I start? You start by thinking about what's common for both. Next year, you are going to have Venn diagrams with three events. You start thinking about what's common for all three. First, if you don't do that, you are going to find this aspect of probability on Venn diagrams very challenging. Then also check if there are some elements that are not part of both events in the question. Like here, we are told that I've got a highlighter, you know that, so let me use my highlighter. So we are told that 25 learners do not do any of those two subjects. So those 25, we can put them outside the two events. Okay? So I'm going to put those 25 outside. So you deal with what's common first, then also try to identify what doesn't belong to both given events. Is that clear to everyone? If you don't do that, you are going to find Venn diagrams a bit challenging. But they are easy now. If you follow what I'm telling you, you are going to find Venn diagrams very, very easy. Your heartbeat won't increase because you saw a question on a Venn diagram. If you follow what I'm telling you, first you identify what's common for both. If it's not given, you put it as X. Then identify if there are any elements that are outside the two given events. Sometimes they won't be there, which is fine. But if they are there, then you put it, like in this case. Then, if you look at the question, we have got 55 learners who are doing mathematics. Among those 55, it is possible that some of them may be doing what? Life sciences. In this class, there are learners who are doing both maths, they are also doing what? Life sciences. So those who are doing both x. So how many are doing maths only? It will be 55 minus x. So we have 55 minus x. Remember, these x, they belong to both maths and also life science. Then there are some learners who don't do maths, which means they will be doing maths literacy and what? Life sciences. So the total of those who are doing life sciences only is going to be 80 minus x. So this is your first Venn diagram. In actual fact, you're supposed to draw two of them. Okay, one in terms of x, the other one after finding the value of what? Of x. Are you following? Huh? Are you following? Are you okay? Is it clear what I'm saying?
Is the format given for very two Venn diagrams or only for one?
Okay, it's for one. Here it's only one Venn diagram. Okay, then from here now, let's calculate x. So to calculate x, we add 55 minus x plus 8 minus x plus 25. That's one method. Can you pay attention? Pay attention. Okay, so you add all these values in terms of x1, 2, 3 plus 25. They add up what? 120. That's one method. There's a second method which I don't normally like to use it to avoid confusion. You can subtract this 25 here from 120. What will be the total? 95. That 95 will be equal to that plus this plus that. Does that make sense? Huh? Yes, so you subtract those who don't do any of the two subjects from the total in the sample space, then you get 95. That 95 will be equivalent to 55 minus x plus 8 minus x. But in my case, at this stage, well, this is your first time, we'll just add what? All four. They add up to 120. Okay, allow me to move on to the next step. I'm going to solve for x. So if I want to solve for x, it will be 55 minus x plus 80 minus x plus 25 equal to 120. Then minus x and positive x cancel out. Okay, remember this is probability. So when you calculate x, x cannot be a negative answer. No way. No way. Yes, if it's 0, it means that there's no intersection. If x is 0, it means there is no overlap, which means we are dealing with what are called mutually exclusive events. If x is 0, it means the two circles cannot what? Overlap. Yeah, you can get that. You can. So 55 plus 80, that's 135 plus 25, you get 160. 160 minus x equal to 120. Okay? Then, now this becomes a grade 8 linear equation. Grade 8 linear equation. Okay, I discussed this before. You take the 120 to the left, you get 40. And this is the same as x equal to 40. So if you wanna then draw your final Venn diagram now, after considering the value of x, it will look like this. So that will be maths, and then you've got life sciences. So this is life sciences, that's maths. So we have now calculated the value of x, which is 40, right? Now it's 40, then obviously we've got the 25 there, then 80 minus 40, that will give you 40, 55 minus 40 will get 50. So this is the final Venn diagram after finding x. Yes? No, the whole question for the Venn diagram is 4 marks. The calculation of x, it should be a separate question actually. Okay, but the construction of the Venn diagram, that should be what? 4. Then finding x may be 2 marks. And then after that you do calculations now from the Venn diagram to determine probabilities. Okay. So let's do the question on probability. Let's calculate the probabilities. So 3.2, the probability that Elena is doing maths only. Okay, you go to your Venn diagram. How many learners are doing maths here? It's 15. Okay, you don't have to stress now. So this will be P, maths only, M only. Okay, that will be 15 out of 120, because 120 is the total in the sample space. 120 is the total in the sample space. So this will give you 1/8. All right, I need to emphasize this, and I've said it. Please, probabilities don't have to be converted to a percentage. Okay? Remember, my first lesson, when I first introduced theoretical probability, I told you that probability lies between 0 and 1. If you convert 0 and 1 to a percentage, you get 0% and 100%. Okay? If you convert it to a decimal, okay, you can always have a value between 0 and 1 as well. So if you've got a common fraction like 1/8, it's not necessary to convert it to a percentage. It's not, because of equivalent forms. All right. So I've done 3.2, then 3.4. So 3.3 rather. So 3.3, it will be the probability of doing life sciences only. So if you go to your Venn diagram, how many learners are doing life sciences only? It's these 40, these 48, these 40. They are doing life sciences only. These 15, they are doing maths only. These 40, they are doing both maths and life sciences. These 15 here, they don't like maths, they don't like life sciences. I don't know what they like. Okay? Fortunately, when I was your age, I did both subjects. Okay, so this will be 40 over 120, and that will be 1/8. Okay? Are you following there? Then 3.4, they offer mathematics and life sciences. Okay? Now, this word "and" in probability, it's very, very important. That word "and." Also, these words, okay, only, they are very, very important in probability. So "and" means what? They intersect. Those learners who are doing both subjects. And if you go to a Venn diagram, how many are there? It's 40. Okay? So P, M, and L. That will be equal to 40 divided by 120, which is equal to 1/3. Also, I just need to let you know. Let's say, like in this case, the question does not say that you must leave your answers in simplest form. Right? The question does not specify. Am I right? So if you leave your answer as 40 over 120, it will be correct. Unless the question says leave your answers in what? Simplest form. And also this will be correct. That this one here, 15 over 120, will be correct. Your probability doesn't have to be converted to a percentage. Okay? There is no rule which says probabilities must be as a percentage. No. Okay? Right? So I'm done with that. So let me introduce the new aspects